And we are live. Elizabeth, do you want to start?
Yes. Good afternoon, everyone, and welcome to the closing ceremony of YHack V 2020. My name is Elizabeth.
I'm Justin.
And I'm Zhao.
And we are the co-directors of YHack this year. We're delighted to have all of you here. We had over 700 people from around the world come together to participate in YHack this year. Thank you to all of the hackers, judges, mentors, speakers, panelists, sponsors, and affiliates who made this event possible. We hope that you all had a memorable week building things and learning from one another. In today's closing ceremony, we'll be going over the following. We're going to have finalist presentations from our 5 finalist teams. We're also going to do a raffle, announce the prize winners of our sponsored challenges, as well as announce the overall prize winner of YHack 2020.
Yep. So I guess we'll start off with the main thing for today's closing ceremony and something that everyone has been waiting for, which is the finalist presentations of our top 5 teams. But before we do that, we would like to introduce our panel of judges. Today, we're especially honored to have the following panel of 7 esteemed judges who took their time off their busy schedule to be with us today and to judge the finalist projects of YHack. And especially because this is in a virtual format on Zoom, where I know on YouTube, you only see the live speaker's face on the top right corner. I would like to introduce our judges to introduce themselves. I'd like to pass the time to the judges to introduce themselves in the order that is on the screen. So starting with Albert. I think Albert. Yeah, I guess Albert is not here today. So we just move on to Anthony and we'll follow down the list.
Sure. So my name's Anthony. I'm a developer advocate at Digital Asset. And what we basically do is produce a programming language called DAML that makes people's lives a lot easier when it comes to programming multi-party types of projects. So if you ever have some sort of execution where you need multiple people involved in actually executing the project and actually executing an agreement almost, then we do that. It's basically like a smart contract language, except instead of being very low level, like something like Solidity, this is very high level. You could think of it like a SQL for distributed ledgers, which I think is really, really cool and really, really powerful. And it's super low code too, which is awesome. As for me myself, since I think I was supposed to introduce myself and not demo, I am a developer advocate. And so that basically means whenever anybody is working with demo, I'm there to try to make sure that they get the resources they need, they get the help they need, and that everything that you expect when you're working with any sort of programming language or tech stack is there. And that's what I do for my day-to-day. And yeah.
Next, you can just move on to chat. You can just go on. I think it's easier that way.
Yeah, sure thing. This is Chad Iverson. I work at Accenture Federal Services, and actually just here on my own time, as Zhao mentioned, hoping to see some interesting and innovative projects. I saw a couple pretty interesting projects in the first round of judging, so I'm really excited to see the presentation. So carry on.
Hey guys, Gurinder Singh here. Really excited to be here. I was at YHack 2 years ago as a mentor, so it's a really nice privilege to be here serving to judge these projects. Currently working at PayPal, Venmo specifically. It's a lot of fun, a lot of good things coming out next year, and yeah, I'm really excited.
Cool. Hey everyone, my name is Jason Brooks. I'm a software engineer at Facebook. I was Yale class of 2016. I was also one of the former directors of YHack when I was a student at Yale, so super excited to be back and seeing what everybody came up with from the other side of the table.
Yeah, I guess I am now in. My name is Jesus Del Valle. I am from Bayer, and by the way, greetings from Berlin, where I'm based. And we do kind of biotech and digital and actually innovation management projects. If you ever have a project, something groundbreaking, something completely new in biotech, yeah, some new medicine or whatever, talk to us. Yeah, we would love to talk with you about the collaboration. And by the way, I'm extremely happy to be here with this Yale hackathon. My father was at Yale about probably, I don't know, like 50 years ago. So I am fascinated to be here. Thank you very much for the invitation.
Richard White, I'm head of research and development at Lightbox. We're a platform for property data, commercial property data specifically, including environmental data, all the tax parcel and assessor record type data, and we help facilitate transactions across real estate. This is my second time judging for YHack. Last year was an amazing experience in person, and this has not disappointed this year at all. I also run our internship, both our summer academic, summer internship programs, some outreach internship programs with some local high schools, and some academic year internship programs. Thanks.
Cool. So thank you all to the judges. And now the next thing I obviously to introduce will be the final projects, the final team members of the final projects. But before I announce this, I'd just like to mention how we did the preliminary judging. So what we did was that we had 16 individual judges, and each project was seen exactly 6 times. So the overlapping sets, each judge judged about 15 to 16 projects among the projects that were submitted for YHack this year. And based on their rankings, we have come up with the top 5 finalist projects. And these are the top 5 projects in alphabetical order: COVID Resource App, Maskify, Pincast, Potluck, and Sift. And these participants are right on this Zoom call with us right now as well, eager to present their hard work over the course of the last week to all of you. And so without further ado, I will start off with the first presentation. I'll pass my time over to COVID Resource App. So take it away. I will stop sharing my screen so you guys can. Yeah.
Great. Can everyone see my screen?
Yeah.
All right. Hi, everyone. My name is Daniel. I'm part of the team that created COVID Resource App for this year's YHacks 2020. I'm super excited to present this app to you guys and go over all the features and hard work that we did. So just to talk about the motivations behind the app. So a lot of this was really based around the idea that we're college students and we live in small, dense spaces where we're exposed to higher risks. And a lot of the 6-foot distancing that we have to adhere to for COVID protocols really breaks down in many gatherings, even if they're in small sizes. And we've even experienced this in residential colleges right now that have been experiencing a few cases of breakouts. And so this was really the motivation behind us creating this COVID Resource App. And so the main goals we really wanted to tackle was the social distancing and the contact tracing problem of the COVID pandemic. And so the way we were able to do this was by creating an app that had 4 functionalities, which we'll be going over. The first one is a visual planner. The second one is the contact tracing functionality. Then we have a self-reporting as well as a distance detection function.
So 6 feet social distancing is a little bit hard to do for humans because we can't really judge distances super well. It's hard to tell when somebody's really 6 feet away. This is a picture of one of the residential colleges at Yale where they have acorns set up on the lawn to show where 6 feet social distance is for everyone. So everybody needs a little bit of a visual cue to help us to remember to social distance and also to know how to social distance correctly. Next, please. The problem with setting up stickers in a living room or in any other space is that it's a little bit hard if you have dynamic conditions. In college rooms, sometimes we may have 2 friends coming over. Sometimes we may have 5 people coming over. And it's really infeasible to redo all of our stickers every single time. We need to get out the tape measure. We may need to look at blueprints. We may need to do trigonometry, which I don't even remember how to do. So the easiest way is to come up with something that's simple, that's intuitive, and doesn't require a lot of extra tools, because the less tools you have to use, the less cumbersome it is to figure out how to socially distance, and the more people are going to social distance because of it. So next, please. So our visual planner function, all you have to do is just input the dimensions of your room. The app will generate a mock-up of the room in this rectangle shape, and then you can just tap anywhere on the screen to indicate where one of your friends is going to be sitting, standing, doing whatever. And all you have to do is check to make sure that none of the green circles are overlapping, and you know that you're good on terms of social distancing. The idea is that everything is simple, it's straightforward, it's easy to do, and you can change this up for however many people are coming over. Right now, Eric, Daniel, and I are all in the same room, and maybe from some of their videos, you can see that we're actually sitting in the configuration from our social distancing visualization. So this is hopefully this is a tool that'd be helpful.
Yeah, I am slightly jealous not to be with those guys right now, but it's okay. So COVID-19 is really terrifying. It spreads exponentially, and we have seen this around the country. And for computer science people in the room, the infection looks quite a lot like NARE trees, but we'll put that aside. Contact tracing is essential to contain COVID-19, but how do you keep track of who was close to you? If you go to the next slide, you'll see that you can't really talk to everyone around you. That's kind of awkward. So what's our solution? It's to automate it. It's simple and accurate. So we decided to use Bluetooth for this functionality because it has a range of about 6 feet, and it's perfect for this. You can just turn on the Bluetooth on your app and press scan and relax, and have the peace of mind that your phone will keep a log of who you were in close contact to. Basically, your phone is going to broadcast your email to nearby phones, and the app takes care of uploading the log and the timestamp to a Firebase database for later use.
So another feature that we implemented in this app was the feature of self-reporting. And so this is connected with the contact tracing feature that Himnish just mentioned. And so the problem we wanted to address was how to notify the close contacts that someone near them has been tested for positive for COVID, and we want to do that in an efficient manner. The solution was to store close contacts in a real-time database, and this was used through Firebase. And we want to extract contacts from the last 2 weeks, because those are the most significant, and email all the contacts in the BCC style with resources and precautions as to how to deal with COVID. And so the way the control flow for this feature is that it's we have a button that allows us to access all the close contacts from the database, and we extract their emails and put it into a pre-written email that goes through all these resources and precautions for COVID-19 and BCCs them to all the close contacts to notify them that someone they have been in contact with tested positive for COVID-19.
So I'll explain the final function of our app, the distance detection, and you can see the not live, but the video demonstration of this app working. And the whole purpose of this function is to help build an intuitive understanding of really what does 6 feet distancing really mean in our daily day-to-day lives. So what this does is it projects an overlay. You point the camera at the ground, and it tells you at the point where your 6 feet bubble ends, and it turns green. So if someone is standing 6 feet away from you, you point it at their feet, they should be green. If they're not, they're within your bubble, and you need to get out of there ASAP.
Yeah, so in terms of features, that was it for our app. We came across a few technical challenges throughout this project, one of which is a lot of us didn't have experience when it came to Java and especially mobile applications. In fact, one of the biggest problems is actually having everyone understand the IDE of Android Studio and understanding Firebase. So all these new technologies that we picked up throughout the process was it was pretty challenging, but it had really a lot of rewards. And there were a lot of different APIs that we had to learn in terms of how we were able to access sensors, cameras, Bluetooth, as well as other general mobile app requirements. And on top of that, there was also a lack of unlimited food that normally comes with hackathons. So there were a lot of hungry, sleepless nights that we encountered. And finally, in terms of path forward, we want our app to, in terms of what we could add to it in the future is perhaps better UI in terms of planning, flexibility, room shape functionality, adding more robust APIs, for example, for Bluetooth signaling and contact tracing, as well as some machine learning object detection, which would allow for more advanced augmented reality and camera functionality. So yeah, that was it. Thanks for listening.
Thank you, COVID Resource App. So now I'll hand it to the judges. If you guys have any questions, you can just unmute yourself. I think there's only 6 of you, so.
Yeah, this is Chad. Just had a quick question about your teaming. What was your approach to teaming, and how did you tap into your team's specializations or areas of interest to kind of make it all come together?
Yeah, so we actually had a feature for each person on this team. So it worked out perfectly since there are 4 features and 4 people. And in terms of how we're able to set apart the teamwork and have different people working on different subjects. So for example, Eric had some experience with object detection stuff. He had some experience with some visual components. And so the camera detection for the 6-foot measuring was perfect for him. I had a lot of experience with database components. And so the Firebase application in terms of accessing the close contacts data was perfect for me. And so we were able to tailor each of our experiences for a specific feature. And that way we're able to optimize who got what feature and put it all together into an app.
Great, thank you.
I have a question. You said something about you would have like the contacts, emails of the people registered in the app, right? I mean, I live in Germany, and here we have a Corona One app. Let's call it like this. Like, I think it's more than 50 million people have downloaded the app. However, this getting the email is like a no-go zone here. It's the email, the person is not registered. What is registered is your phone, your mobile phone. And if you get positive with the virus, obviously some computer, some server knows that this mobile phone owner had or has coronavirus, but it's completely transparent. You don't know the person email and so on. How would you have, I mean, obviously there would be many people that would be against giving you the emails. And how do you want to guarantee this data privacy there?
Yeah, so sorry, this is something I missed when I was mentioning the project. And so the way we were able to deal with this email issue is that we sign in through Firebase APIs. We use a Google account to sign in through and identify each user with their specific email. And so I understand the issue of privacy when it comes to people not wanting to give up their email and talking about like not wanting to share that with other people, especially if you tested COVID positive. And so we really talked about all the privacy concerns with this. And unfortunately, in this short amount of time, we weren't able to completely crack down on this, but we decided to settle, because Firebase has very secure, with Google APIs, we have very secure like email. We were able to keep the accounts secure. And so we were able to transfer the emails through Firebase's APIs. And that's how we were able to keep the privacy.
Yeah, and also just to add something on top of this was mostly in terms of the college setting. At Yale, for example, everyone has like a Yale email, and basically if you know the person remotely or their college or their year, you can find their email addresses. So we thought that it was okay to like rely on emails for this specific model, because specifically in a college, it's easy to like track down the email addresses if need be. But to be more specific, I do agree that privacy is a big concern. And if we were to improve on this app, one of the things that we would try to change would be definitely like privacy concerns and anonymous IDs. Thank you.
Hey guys, a bit of a technical question here, but I noticed you have a feature where you can self-notify your contacts if you have been infected or have symptoms. You also have like this graph of connected users from Bluetooth data. If a user on that node says, hey, I may have been exposed, is there any effect to that graph? Like, would someone in passing maybe get a notification saying like, you may have been in contact with someone because they reported? Is that correlation there, or is that something you guys entertained?
Yeah, so those features are actually connected. So sorry, I don't think I made this clear enough, but the idea with the contact tracing through Bluetooth, it's updated to that database through Firebase. And that's where we keep all the information as to user A has been in close contact with B, C, D. And we use that same database for the close contact notifications. And so yes, in practice, what would actually happen is that if two people were passing across the streets, and that someone had tested positive, we would send that email and they would get that notification through email that someone in that database or someone that they had been close contact with has tested positive for COVID.
Why don't you use the cell phone itself?
Pardon? Sorry, can you repeat that?
Your cell phone, your mobile phone contains the database or the previous contacts. And if one of the contacts gets tested positive, then it would show up in your mobile phone. One of my previous contacts. But you know what I mean? There is no like a central database.
I do see your point. I think our previous model was actually based on using internal storage in the phone. But then Daniel actually was the one who brought up a really interesting point. He was like, if we use the Google signing functionality, you don't need to necessarily have your specific phone, or you could sign in from everywhere to check if you got a notification, or you could access it from specific over like different phones. And I think this does require an internet connection, but there's like pros and cons to every method. Internal storage would have been directly on the phone, but then you would only have to stick to the phone itself and not have the transportability of the app. So we decided to go transportability with this one.
Another thing we were thinking of is just another privacy thing. We didn't want anybody else's information being stored on anybody else's phone. That way, if everything is secured by Google, we trust Google to have a firmer lockdown on information than we do. If we store the information on the phone, it makes it more vulnerable. So we chose to have it stored in the cloud.
Cool. Okay, so I think that's the 5 minutes for questions. I think we'll want to move on to the next presentation because we have 4 more to go. And so without further ado, we can move on to Maskify. You can take it away. I think screen share is enabled.
Hi, can you all see my screen that I just shared? Yes. All right.
Yeah.
All right. Hey, everybody. Hope everyone's doing well. My name is Arjun, and along with my teammates, Matthew, Simon, and Varun, we built something that we're incredibly excited to share with you guys. But before I start, I want to spend a little bit of time talking about something that's been on everyone's mind this year. In today's climate, where COVID cases are spiking, the importance of wearing a mask cannot be overstated. Currently, many small businesses are beginning to reopen, but they face the challenge of enforcing both social distancing and mask wearing, all while running their business. Enforcing these rules are paramount to maintaining safety in today's world. Unfortunately, where there are rules, there are people who break them. As throughout the year, we have seen the rise of people who deliberately disobey mask mandates when entering into stores. These anti-maskers not only disrespect and waste the time of the business owners, they also pose a health risk given today's climate. This problem got us thinking about how we can use our passion for computer science to address an issue that's more prominent than ever. So we came up with Maskify, the AI-powered smart lock designed to keep anti-maskers out. Imagine you're a business owner and an anti-masker is walking up to your door. Currently, there is nothing you can do to stop them, as they possess the ability to enter the store and cause issues. Maskify solves this problem using computer vision to scan the faces of every customer entering into a store. If Maskify detects a person who's not wearing a mask, it automatically locks the door and won't open it until they decide to comply with the rules. Thus, Maskify eliminates the hassle of the arduous and oftentimes fruitless task of arguing with anti-maskers, allowing business owners to run their business in the safest way possible. Now, let's spend a little bit of time examining the core components that power Maskify.
So the first component is the computer vision side, which will take the input from any camera feed and run it through our computer vision backend. So the first step is to extract the faces from the image using a HAR cascade classifier, which looks for face-like features and returns a box surrounding that face, as you can see in the image. We then trained a convolutional neural network on thousands of images to recognize whether each face that's returned is wearing a mask or not. Depending on the result, the app takes the appropriate action of either locking or unlocking the door.
And of course, we know that computer vision isn't always perfect, right? However, Maskify actually transcends the accuracy of the underlying computer vision technology with our processing algorithm. Instead of just considering what it has seen at a specific instant, right? Maskify actually accounts for what it's seeing over a period of time. So this means that, even if the underlying classifier isn't always accurate, no big deal, because Maskify can always deliver accurate results, classifier or not. And in order for Maskify to achieve societal impact on the scale that we want, it's important that anyone should easily be able to implement Maskify in their own business. And to this end, we had to make Maskify work with as many locks as possible. However, I mean, there are tons of smart locks out there. How do you actually go about adding support for each and every one? It's a Herculean task. So we leveraged Google Assistant, and through that, we were able to integrate any lock that worked with Google's tech. We're proud to announce that Maskify can connect to and works flawlessly with any smart lock that a user might own.
So in order to integrate this mask detection into a live webcam, we developed an iOS app that many iPhones can use. We created a basic front end using Swift and have a button to stop and start recording. While our interface is relatively simple, as you can see here, the bulk of our effort here was spent in working with Apple's AV Foundation framework to capture and stream this data to the backend. And I'll pass this off to Simon to explain the details.
So our essential idea was to use WebSockets to set up a continuous video stream. And using the socket.io protocols, we were able to transfer the video to the back end, and then the back end was able to transfer any data to the front end, such as the bounding boxes.
And obviously, not everyone has spare iPhones just lying around that they can dedicate to Maskify, and we get that. So in order to achieve our goal of making it possible for anyone to use Maskify, we needed to create an alternative input system. So Maskify operates smoothly with any webcam a user might have. And this just takes out the need for a spare iPhone altogether. And I mean, obviously high-end webcams, wireless webcams work exceptionally well, but it can even work with generic budget webcams you can get for less than $10 online. You can even connect it to the integrated webcam on your laptop, and it should work.
All right. So there are a few places where we see improvement for Maskify. The most straightforward addition would be creating an Android app that streams video in a similar manner to the iOS app. Another thing we could do is we could have Maskify broadcast a message about mask wearing, which can help remind patrons who may have forgotten to put one on, but are willing to do so when prompted. Lastly, we think there is room for creating a more inexpensive hardware lock solution. This concludes our presentation. Thank you for listening. And does anyone have any questions?
Hey guys, yeah, I can start with a question. Great presentation. It looks like you guys have built some pretty cool modular technology that has like kind of individual, pieces that can work nicely together. Can you see this technology being integrated into something else? Like maybe, requiring people that need to wear a uniform for work as a medium, or have you guys thought of maybe integrating this in another way?
Well, currently our classifier is dedicated directly to masks, right? But the cool thing is, first of all, since we integrated Google Assistant, Google Assistant works with tons of devices, right? Not just locks. So we actually went over this in our video, but there's an example where, let's say you want to turn the lights off when someone without a mask walks by, right? Or literally any device you can think of, really. And it works completely fine. And actually creating a different classifier for a different thing would be possible as well. And we get that working with Google Assistant.
Yeah, and just kind of adding on that, the way that our neural network is built, it's really simple. If anybody wants to check out our GitHub repo, just to add in the photos of things that you want to classify into 2 different categories and train it. So if we wanted to classify something like people wearing a uniform for work, it really shouldn't take that long given our current architecture.
Thanks for clearing that up.
I have a question, maybe this is for Varun. Can you elaborate more on how your algorithm overcame some of the typical challenges with classifiers? And I think you mentioned that it learns over time. If you wouldn't mind just elaborating on that a little bit, that would be great.
Right, so essentially, we can't accurately classify every frame, right? Obviously, even if we try to create the most accurate classifier ever, occasionally it'll fail. And that's completely fine, because the fact of the matter is, if someone's approaching your door, they're not going to just barge in half a second, right? They'll take time to walk up, and you'll have a bit of time in which you can classify their face, right? Figure out exactly what's going on. So we took advantage of that fact. Basically, what happens is we take the frames over a set period of time. Mm-hmm. I think in our case, it was something like 12 to 15 frames. And we say, hey, if you see someone without a mask in 2/3 of these frames, then lock the door. And if they walk away and you see someone, I think it was 4/5 of the frames, right? Have a person if everyone's wearing a mask in 4/5 of the frames, right? Then you can lock the door again. So the algorithm has a unlock the door. So the algorithm has a predisposition to locking the door, right? And preventing anti-maskers from getting in.
Okay, thank you.
Thank you. This is exactly what I was thinking. I mean, many of people in need of this kind of things would be small stores owners, right? They have a small place, therefore now with the COVID situation, actually, and also for their own business, they tend to leave the doors open, yeah? But then using your solution essentially would mean that people would need to close the door, yeah, before the people come. And this is what, which is not good for the business and for the virus, so that you need circulation. And how do you want to try to prevent this situation instead of using the lock, for example? Yeah, I know you have this speaker support. This is great, a very good idea, I think. Yeah, but what do you think about this? And again, thank you for your project. I like it.
Yeah, thanks for the question. I agree that for some businesses and how they operate, it could be a problem to have the door closed. But I do agree that at times that could cause problems with COVID and this circulation problem. But I do believe that having the door closed in this way and then not allowing people to enter is likely still the best possible solution in most cases, in that a lot of small businesses, they already might do close the door, for example, if the outside is really cold. So, you know, they have to, they close the door in most scenarios already. So as a result, I do believe for the most part, this current solution with locks will work. And in the situations where it doesn't, I do believe the speaker support is likely the best way.
I have a question. I took a look through your GitHub repo and I saw that your training data set was actually, it looked like you created the training data set yourselves. Can you talk a little bit more about how you kind of came about that and, you know, what went into that process? It looked like you were kind of like relaying fake images of masks onto, you know, images of faces.
Yeah, so that was actually, we didn't actually make those images that way. It's just the data set that we downloaded that had it in that fashion. I think we also tried to include some more images that were of like different color masks at different angles, whatnot, just so we could have a little bit more diversity, more flexibility in our model. But definitely if we wanted to go about making our model stronger, I think adding in more data and feeding in more examples would be the way to go.
Cool. And I think that's time for the second presentation. So thank you, Maskify. And with that, we'll move on to Pincast. I think Maskify, you have to stop screen sharing for them to start. Pincast?
Can you guys see my screen?
Yep.
Right now. Everything good to go?
Yep.
Okay, sounds great. Yeah, really excited to be presenting our app today, and greetings from Shanghai. Just to introduce sort of the background and motivation of our project. All four of us are really avid podcast listeners, especially in the times of COVID. There's a lot of downtime, a lot of, you know, time to go on runs and stuff like that, listen to podcasts. And we feel like the podcast medium has really been growing rapidly over the past few years. And this is the case because there are several key characteristics specific to podcasts that make them very unique. Number one, they're quite personable between sort of the person talking and the listener. Number two, there's a really nice educational aspect to it. You can learn a lot through listening to podcasts. Number three, there's a lot of community related potential to podcast listening with, inside jokes, popular recurring segments and whatnot on each episode. And we believe that while there are many podcast listening apps out there currently, like Stitcher, Apple Podcasts, Spotify, we feel like these podcast platforms don't necessarily really bring the most out of the potential that comes from these three characteristics. So with Pincast, we aim to create an app that really allows us to really tap into the educational and community-driven aspects of podcasts.
Yeah, so with this in mind, our solution is actually an interactive podcast platform that would allow us to reflect on select sections of the podcast that users have listened to, and also discuss with the community to understand what other users have been thinking about while listening to the podcast. And so we thought that our podcast should include the following features: the ability to play the podcast while listening and interact with it at the same time. And also you are able to pin specific sections that you would like to go back to or potentially discuss with other users. And also the ability to obtain more information on specific sections, such as a quick fact or a potential picture of what the section is mentioning. And finally, we would also like to have the podcast have a huge discussion section on select sections where users can talk about what they thought about this section, rather than having users discuss on the entire podcast as a whole.
So Pincast supports both mobile and web platforms. And to kind of give you a better idea of what it does, we'll run through the prototype real quick. Next slide. Yeah, so this is the mobile prototype that we created. First two screens are pretty much standard podcast screens. But with the third screen, you see like a pull-out tab with all the different pins, for the most recent pins, and there's like the episode and the podcast name on those pins. And then when you look at the fourth and fifth screens, these are like the two listening modes for our app. There's like a live mode and a reflection mode. The live mode allows you to pin podcasts as you're listening to it. So it's kind of more of an engaging mode, while the reflection mode is a place for you to come back and revisit your pins and discuss with the community about different sections of the podcast. Next slide. So here's the prototype. Here's a prototype of the part of the web app that we implemented with functionality, as some of you may have seen in the demo video. It kind of combines both the reflection and live modes of the mobile app. The middle section, the middle column, scrolls along with the audio, and you can see like the different pins on that line, and as well as how the pin looks on the screen. So those correspond to different things like facts, key facts, and things like book recommendations that we can retrieve from the podcast. So a little bit about the backend technology. For the audio transcription, we used Google API, the Google Speech to Text API. This gave us both the transcribed text as well as timestamps for each word. The Meaning Cloud API allowed us to do some natural language processing. It allows us to detect topics from within the text, as well as categorize the text. We also scraped Wikipedia, and using all this information, we generated a pin object, which is our backend representation of a pin, and includes all that information in the JSON file.
So to briefly touch upon the database, basically in order to get our UI to sort of display pins and whatnot at a more seamless sort of real-time speed, we stored a lot of the sort of backend work for a select group of podcasts in a MongoDB database. Additionally, we created basic schemas for users as well as pins and podcasts. You can kind of look through the basic sort of information stored in each of those. And then in terms of connection to front end, we're running fetch requests on React and continuously checking for sort of new updates from the database.
Sorry to interrupt. Time is up. So could you just wrap up?
Okay, yeah, I'll briefly talk. This is our front end tech. We've already mentioned it: React Router, Material UI.
And yeah, so for the next steps, we are thinking about implementing a larger library of podcasts, potential more community features, smoother transition between the backend to the UI, and also the fully functioning mobile application. Thank you. Yeah, that's the end of our presentation, and please ask us any questions.
This is Richard. You mentioned Figma as one of the tools in the design front end. I think in your video presentation, can you explain where you integrated that, how you used it?
Yeah, so Figma was mostly for our prototyping process because yeah, okay. So Figma was mostly actually for our prototyping purposes. Those were just to create like a lo-fi, mid-fi, and also a hi-fi prototype by our designer, so that the developers in the end could actually create a fully functioning product on the front end. And that's kind of what we use for Figma.
Thanks.
Hey, hey guys, quick question. I noticed you had a quick fact option along the timeline of the podcast. Can you tell me like how, from the UI to the backend, how that happens?
So I can take that, and Kevin, if you can add on to that if you have any additional comments. But basically, we've run sort of the Google Speech to Text API, the NLP stuff, and then with Beautiful Soup, we've gone sort of to Wikipedia. So the NLP stuff has identified key sort of nouns, key phrases within each sentence of the podcast. And then we've gone in, used Beautiful Soup and scraped Wikipedia for just like a key introduction to those key facts. So the example on our demo, for example, it picks up on the fact that Supreme Court is a key phrase in that sentence, scrapes Wikipedia for just basic facts about the Supreme Court, and then displays that sort of on React. So React will do a fetch request. It'll be in our database with respect to just like the full JSON object. It'll look for that specific timestamp and then pull that data and display it on React.
Cool, thanks.
I was just curious, did your team members have experience using the Meaning Cloud APIs or even the Google Cloud APIs? And I'm seeing heads shaking. So what did you learn as you went through the process of trying to get something all pieced together over the past couple of days, given your lack of or limited experience with these APIs?
I guess we had a general lack of experience with natural language processing. And so I think one thing we definitely learned about was the limitations of the APIs that exist out there. For example, we talked a little bit about speech diarization, which like identifies the different speakers in the podcast. And we noticed that the Google Cloud API wasn't able to do such a good job with that. So we weren't able to do that with our closed captions. We just had the text without the speakers. We thought that would have been a cool feature, but we weren't able to do that. And then also another thing with the Meaning Cloud API, we tried to summarize the entire podcast. We didn't have very high hopes, but of course, yeah, that also had its limitations there. So yeah, that's, I guess, one thing we learned. Because,
yeah. Okay, great. Thank you.
Do we have any other questions from the judges?
Yeah, are there any ideas you have, since the language processing is somewhat limited? Are there other ideas you have around making that more interactive, more community driven, things you would like to add to Pingcast?
One thing, yeah, so for the community driven aspect of it, I think there's a lot of potential there, especially with respect to the pinning feature. I think with a lot of these apps right now, there's not a lot of details about the specific points within the podcast. And we were thinking one potential feature that would be interesting would be, so when you load up the app for a specific podcast, it would pull all the information from like different pins that users made, and like show kind of like in SoundCloud as you're listening to a song, like different points in the podcast that were popularly pinned, and that way people could potentially check those out, and also kind of you know, on the far right column, like make comments specific to that time frame, and people could kind of see that, and that way the comments would also be very tailored to like specific talking points in the podcast, because obviously for at least a lot of podcasts I listen to, they might touch upon like 3 or 4 subjects, and there might be an interview, so there are a lot of different things going on, and being able to segment and encourage discourse with respect to those specific segments would be like a huge priority for us.
Yeah, that sounds really cool. Thank you.
All right, so that's it for Pinterest. Pincast, sorry, my bad. So next we move on to Potluck, who can, yeah, you can take it away.
Hi, everyone. We would like to present our project for YHack v 2020 that we named Potluck. Recently, COVID-19 has drastically shifted the business models of restaurants towards online platforms. While larger restaurants have been able to thrive during COVID-19, we have noticed that small restaurants have unfortunately been left behind. With that in mind, we designed Potluck, an innovative way to connect consumers with smaller restaurants with a community-centric focus. So how does Potluck benefit consumers and chefs alike? With our user-friendly interface, chefs are able to easily add their restaurant or service to Potluck's database. Users are then able to view a personalized dashboard of nearby restaurants based on their food tastes and sentiment analysis of previous customers. Chefs are also able to view and respond to feedback on their food, creating an interactive environment that benefits both chefs and consumers.
So the main problem we were trying to solve regards COVID-19, and we all know how that's transformed completely how restaurants are supposed to be financially viable. And so currently there's pretty much only a few methods in the market, such as Grubhub and DoorDash, that really allow restaurants to use online methods. There's a few problems with this that really stems from how small businesses cannot succeed under these methods. For example, restaurants have to give a flat premium of at least 20% for every single sale they make. Additionally, restaurants are approved case by case based on projected profits. And also the search algorithms in these apps are going to be very top heavy. They're going to favor, the Chipotle and the Subway, but not really the small businesses on the bottom. And taken together, this suggests to us that there's no meaningful way currently for small restaurants to survive during the pandemic.
So to address this issue, we propose Potluck. So Potluck is an easily accessible web app, free for both consumers and restaurants, given our premium free service, and built to promote small restaurants and chefs in this new remote world, effectively helping to build and maintain a sense of community. And Potluck helps connect chefs and restaurants to nearby hungry consumers, while also ranking each restaurant with natural language processing based sentiment analysis of user-provided comments.
So we're quickly going to go over the technical workflow that was used in our app, which will be demoed right after this. So it starts on the left side. We have the Python and the Flask front end. This is where both users and chefs are going to be able to access the app and speak to one another. And if we start on the bottom left, we have the chefs. So they're going to be sending in their user input. So that's stuff regarding their restaurant, the location, the genre, description, etc. That's going to be sent straight to our Google SQL database and stored for the users to access later. So let's go to the top left now with the users who are also going to put in their input. Stuff like, what type of food do I want? Where do I live? This information is going to then be processed to get rid of possible errors. And then we're going to send it to a prediction algorithm, which combines a few things. It combines the restaurant data from the SQL database. It also uses pre-built Google NLP models, as well as a Google Maps API, which will tell us driving distances between the user and possible restaurants. All of these taken together will be used in a prediction algorithm that combines these features to get a dashboard that will rank the restaurants that we think are the most suitable for the users. So this is sort of our final product, and now Pranav is going to demo this to see how it works in real life.
All right, awesome. So I'm going to hop into a virtual machine where we have our Flask server running. All right, so now we have our main Potluck site. So we got HTTPS going. All right, so essentially on this main page, we talked about the service that we have, how it works, our mission, and our core values. And so I'm hungry to get started. So I'm just going to go to the restaurant listings. So right here, our default listing is just going to have the address, style of food, phone number, these custom tags. And this is, I guess, a huge part of our ranking, which is the sentiment analysis, which is essentially uses natural language processing to get the average sentiment in the comments. And so that's really creating like a very personal way to rank how these restaurants are listed. And we can see like more negative rankings are at the bottom. All right, so I'm going to go ahead and do a filter. Basically, I would most likely want to find places that are near me. Maybe I'm hungry for some Vietnamese food and I really want it delivered. So I'll just search for that. And so you can actually just put in your zip code. You can put in some coordinates, and that's just the power of the Google Cloud Maps API. And so right here now we have a map with the rankings. So you can see that the Vietnamese places came first, and it shows driving distance ranked by the closest. These places aren't real addresses, but you can see they came right at the top because they matched for delivery. And so all the other places are just ranked by driving distance. And so let's say I want to go to Pho Noodle Soup. I just click the 2 on the map, or I can click the 2 in the listing, and it'll send me to that page. I think one of the things to notice is the order is just a matter of calling the person who runs the shop. And so that really keeps our interactions at a very personal level, which is the idea behind Potluck. And so there's comments. I could add a comment right now and just be added automatically. And so I also want to show you guys the restaurant listings. So I'm able to set the style of food. Maybe I can add like a menu item. So I'll just add right there. Maybe I want to add a tag for like something that's like cheap. And so if I were just to submit this, it would add it to our list. So I'm going to search for the address again, and now we'll see.
I think
Awesome.
time is also up, so could you just wrap up if you could?
Yeah, and so I guess we just see right here, this is the last, the thing we just added. And so it shows up on the map too. Thank you guys so much for listening.
I have a question.
So, go ahead.
Thanks. Yeah, I just have a question around like the integrity of the system. So do you have any thoughts on how you can ensure that like businesses won't use comments to basically game like their ranking? It sounds like that's like the primary driver of how businesses are ranked here.
So one of the key steps we want to take from here is to create an account system, very similar to something that Grubhub or DoorDash has, which would ensure uniqueness based on something like a credit card. And the idea here is that you don't want to have duplicates. You don't want to have people gaming the system. And additionally, another thing we were thinking is if we can have an account system, we can also start tracking user preferences about which restaurants they're going to. And that's also something that we can build on from there. But definitely regarding the question of the system, gaming the system, I think if we have a user account system that has some uniqueness aspect, it's very difficult for there to be many flaws with that.
I really like the working demo and appreciate that. It was good during the presentation also. I haven't seen any pictures of food. So I'm in a food and a menu and a restaurant app. Do you plan for not only the restaurant owner to be able to upload menu items, things like that, but also photos?
I think that's definitely a feature that we could probably easily add. I mean, yeah, that's definitely helpful for users to be able to see pictures of the food that they want to order. And yeah, I think that'd definitely be a useful addition to our program that we could probably do quite easily.
One question. The reason why there is a premium is that, I mean, these services, they need to entertain a database and the software security and so on, and marketing for this. How do you want to be sustainable? How do you want to finance your business? Do you also are going to get a premium or some ads also?
The way we think about it, I think the most reasonable way would be the ads. Our whole message is that we don't want to be taking the profits away from these small business owners. That's sort of against what we're standing for. You're right, especially if this were to grow to a larger scale, we would need a bit of finances, for example, to maintain a database or to do something like a call center or help support. So yes, I think the most reasonable way here would be to do ads. We definitely don't want to be taking things away from our chefs and small businesses.
Right, maybe myself, I mean, I live in Germany, and here we do have some delivery systems, say like this, where many restaurants are included. The way I understood you is that you wanted to kind of help the community, you know, some people that live here close to me, and that, but actually, if I think of those things, I pick up the phone. And then, hey, do you have a garlic soup for me today? I mean, how would you compete against people picking up the phone? I mean, which is the simplest thing that I can think of. Yeah.
I feel like it is a similar model to that, where like you are still having these like personal connections where you do call people on the phone to connect with them and like get food. I think what our platform's kind of facilitating is just like seeing more connections. Maybe you didn't know that down the street somebody makes like really great, like a really great meal that you would really enjoy. So I guess that this is making those connections.
Right, so we love the idea of having personal connections, like you said, between communities. And we think that this app is more of a way to create more of these connections rather than replacing them. So we can use this app to forge new connections. And from then on, there can be a closer personal relationship. And that's something we would love to have happen through our app.
Thank you. I love this community sense. Thank you.
Thank you so much.
Any last questions from the judges? We have 30 more seconds.
Kind of piggybacking off of Jason's question earlier about you guys mining this information, did you run into any challenges when, using the sentiment analysis? Like, did you have to get rid of any noise or, duplication manually?
So I think that's something that the Google API already does. So, so what we're doing right now is we have some user input a comment, and that's in the form of like a sentence or multiple sentences. And then what the API is doing is it filters any like, I guess, non-alphabetic characters, non-ASCII characters, and then it also categorizes each word. And so based on that, it can calculate, what's the sentiment of each word, and then what's the sentiment overall for all the comments in that restaurant. So it's definitely doing some sort of filtering where it's not including any invalid comments.
Neat. Yeah, thanks for clearing that up.
Cool. So I guess that's it from Potluck, and now we move on to our final finalist, our last finalist for tonight, wherever you are, whatever time of day, wherever you are, which is Sift. So Sift, go ahead.
Okay, great. Hi guys, my name is Joseph Kahn.
I'm Sophie Wu. And I'm Connie Chang.
And together we created Sift. Sift is a YouTube sentiment analysis algorithm that allows for YouTube creators as well as viewers to analyze the sentiment of the comment section of an overall YouTube video or an entire YouTube channel altogether. For content creators simply don't have the time to read through all their comments nowadays. What Sift does is it allows for content creators to evaluate the positivity of all their comments on all their videos. Contemporary tools such as the likes and dislikes ratio have been shown to be completely unreliable, as longtime subscribers typically pump up the like button in order to bump up the video in terms of the YouTube algorithm suggesting that video. What Sift does is it allows for creators to tailor their content over time to create a more positive commentary reaction, and in order to create foster a more positive community in general. Additionally, Sift also allows creators to manage their comments more effectively. They can choose to delete overly negative comments engage with strong positive comments, as well as understand all the differing perspectives on their most controversial videos. In terms of benefit towards individual users, one of Sift's most significant benefits is the fact that it allows for people to evaluate the overall sentiment of an entire YouTube channel and an entire YouTube community. With an increasing emphasis on mental health, users can use Sift to see how positive a YouTuber's community is before choosing to invest significant amounts of time in subscribing, watching videos, as well as donating to the channel. Just briefly going over how we technically implemented this, we used the Google Data API in order to scrape all the comments from either an individual YouTube video ID or from a specific YouTube channel. And then using the pandas library as well as Python, we then got the response from the YouTube Data API and exported it to a CSV file, which was used by the YouTube sentiment analysis algorithm in order to rank all the individual comments. And then from there, we implemented a Flask server, which was able to serve the results of that to the front-end React app.
So one of the biggest technical difficulties that we had in this project was that two of us have a design background with little to no coding experience. One of us specializing in front end and only one of us having experience in back end, and none of us having experience with data analysis. So one of the big challenges for us was being able to take our code and actually produce information that would be valuable to the user. Next slide, please, Joseph. Thank you. So for this, we designed our app to produce a couple of sets of information. Firstly, obviously being able to look at the overall sentiment of any particular YouTube video, as you can see in the archive photo. We thought that was especially important because that meant you could look at YouTube videos relatively depending on their actual overall sentiment. Also being able to still look at qualitative information, such as the top and most engaged with comments, or the most polarizing, meaning the most positive or negative comments, we thought was also especially important because that means that, especially for more controversial videos, you might have a better understanding of exactly how that engagement actually works. Most importantly, what Sift offers its users is an idea of genuine engagement and what the genuine reactions of the people who interact most with that YouTube video is, meaning it would probably also have applications towards people looking for YouTubers to sponsor specific products or to offer specific commercial values, because this means you can actually evaluate not just how many views and how many likes a video has, but also like the actual impressions that that video produces.
On to design. So for our website, we wanted to make it very fun and colorful and angled towards probably a younger audience. But also we wanted to emphasize that while this is a metric for social media, we don't want social media to be taken that seriously. It's also a very simple and easy to navigate site that's heavily icon based. And we developed a visual system that makes things a lot easier to navigate, which is in the settings page. And most of these icons were created in Adobe After Effects, Illustrator, and Photoshop. Yeah, so this is the settings page that I mentioned earlier, and these three icons were just made to declutter this screen because it has a lot of text on it, and also for our visually impaired users who can more easily distinguish without use of color. So that pretty much wraps up our presentation.
Thank you so much, everyone, for listening.
Yeah.
Very interesting.
Question.
Go ahead.
I just wanted to find out, how did your team overcome some of the challenges in the area of data processing that you just described earlier?
Yeah, so I think I can speak to that in terms of scraping the data, and then I think Sophie would be a better candidate for talking about the actual individual sentiment analysis. But in terms of data scraping, I think the most significant challenge that we faced was working with the YouTube Data API. The main thing is because, well, I had experience working with it in terms of JavaScript. They're the YouTube support. The Google's documentation for JavaScript isn't the greatest. They don't actually have a JavaScript library. And so what we ended up having to do was we had to then look at using it in Python instead. So we had to choose to implement it in Python and then set up a Flask server in order to then interact with the front end, which made it significantly more challenging. But at the end of the day, we came up with a solution.
Okay, great.
And Sophie, if you want to talk about the sentiment analysis.
Oh yeah, sentiment analysis took a little bit of trial and error because there are a fair number of natural language processing options that we had and that we looked into and that we eventually figured out how to use, but especially because YouTube comments can be so informal and like sometimes things that can seem really negative, for example, like certain swear words that people might use as compliments these days might actually be positive. We had to figure out workarounds for that. So we ended up going with TextBlob, which is an open source natural language processing tool for Python, and making a couple tweaks here and there just to make sure that like it wasn't taking things too literally and like it wasn't too hard to like figure out like a lot of trends for like YouTube content creators these days and like some Gen Z lingo to like plug in there. And yeah, eventually we ended up making sure that it could at the very least evaluate whether or not a comment was mean or not mean, and we figured that was good enough.
Yeah. Okay, great, thank you.
One usual issue with this kind of systems, yeah, is like this scrapping comments and so on. At some point that the provider doesn't like this, yeah. And I mean, YouTube is pretty open and maybe you can make it there, but I really don't know things like TikTok or the new kid on the block, this OnlyFans, yeah. And there, essentially, a software like yours would make a lot of sense, yeah, because of the many comments for that one celebrity or star gets and so on. How do you want to overcome this? I mean, I don't know if you have been there before. The web pages, they close access to you after they realize you are scrapping the comments or the content. Yeah, this happens all the time. How do you want to overcome this?
I mean, I think that in general, I don't really think that there's a main reason or like a very high chance that YouTube would want to shut down like our app. And that's just mainly because like all the data that our individual like API uses is mostly like pretty much like public information, right? Like it essentially is using a read-only scope, which means that anyone with like that signs in from incognito can get the like information that we're getting. In terms of like workarounds, like it would be pretty tough because if they did like shut down our app, like we pretty much like would lose our main data source. But I just think that like in general, I don't really see a high amount of like risks in terms of like them trying to like I guess avoid like ourselves like scrapping the data. And like I think the main reason that I think that is because like there are also like a lot of like algorithms that are already out there that are already like that like YouTube creators pay a lot of money in order to like manage their own like comment sections altogether. So I think that like our app is not very different from what is already being done. It's just that our app like is like the most open source, and it also is able to most directly allow for engagement without having like a massive, I guess, barrier for like smaller channels.
Also, if I could jump in quickly, I think the most important thing is that our app aims to have the same goals as the content platform that it would be helping, because it aims to build better community and build better, more genuine engagement with content creators, because it means that they can better understand the actual engagement that happens with their audience. So long as we can like manifest that properly, I can't see any reason why platforms wouldn't want the creators to be more empowered to create more positive and better content.
Did you, when you were processing the comments that just to design this, did you find anything interesting about how sentiment was on these various websites on YouTube?
Oh wait, Joseph.
Wait, no, sorry. I was just gonna ask you to repeat the question.
Oh yeah, I was asking essentially when you were actually designing this, I assume you ran through some comments on YouTube. So I was wondering if you found any interesting insights on how sentiment is on YouTube.
Yeah, I think Sophie would be a better response for that.
Yeah, actually, funnily enough, when this idea was first pitched to me, I wasn't particularly enthusiastic about it because I had the impression that most YouTube videos would have more or less very like monocultural comments where most people would have the same opinion about the video, because most videos that I watch, I just go to the top comments. I see most people saying like, wow, this is a really great song. And I assume that's the way it goes, right? But I think it's actually really interesting to note that like top comments are not indicative of like the overall impression of a video, since obviously since running through a lot of these videos, we found, and you probably saw in these slides, many videos that had like a wide range between the most positive and most negative comments in terms of their polarity. So I think that just speaks also to the value of this project, because it means that you can look past what YouTube might want you to think is a very like single linear, like one perspective point on a piece of content.
Yeah, thank you so much. So time's up for questions for Sift. Now I think Elizabeth will elaborate on the breakout room arrangement and what we want to do after this.
Yeah, so thank you to all of our finalists for those amazing presentations. We are going to invite all of the finalists to please leave this Zoom call and join the YouTube live stream now, and Zhao's going to drop the link in the Zoom chat. Meanwhile, our judges are going to move to a breakout room to deliberate on the overall winner. And we'll be moving to our raffle, which Zhao's going to be leading.
Cool. Okay, so I guess this is the time that most of you who are watching the live stream are waiting for, which is the raffle. Yeah, the raffle. So I guess we have mentioned this throughout the course of the whole of last week, that there was a raffle going on, and we're raffling away these cool tech like a Google Home Mini, and some gaming mice. So from all of these events, we have compiled the list of people who have submitted the raffle tickets at each of these events. As you can see, we have had fireside chats, panel discussions, as well as talks throughout the week. These are organized by us, and as promised, we have 2 raffle tickets for each one. And then for each of the sponsored workshops, we have 1 raffle ticket. So you can see that the raffle tickets are just numbered from 1 through 175. And we will actually just use random.org to pick a raffle ticket. Okay, so let's start. I guess it's a bit anticlimactic because you cannot like have drum roll here, but we will hit the get number button and we will have our first raffle winner. Wait, yeah, there we go. So it's 159. And who is 159? Let's take a look. So Kingsley. Kingsley is one of them. If you're in the chat, just type something in the YouTube live chat. We will look at it later. And then we'll move on to, so this will be for the, sorry, I guess I should have mentioned the order of things. So we have 2 gaming mice, 1 Google Home Mini and 2 Google Homes. So this will go from the gaming mice to the Google Home Mini to the Google Home. So this would be one of the gaming mice that we have. And we will go again to 133, which would be Leslie. I should just mark it somewhere. Let's just do this. Oops. And then sure. And then the next thing would be the Google Home Mini. You get 109, which would be Angela. If you guys are there, okay, Leslie is here. I see her in the chat. I think Kingsley is not here, so Angela is the Google Home Mini for now, at least. And we'll go again for 22, which would be, where is it again? There we go. Ellen Wang. If you're here, type something. I see Angela in the chat as well. Ellen Wang, if you're in the chat, I think we'll roll another one for Kingsley as well. Just because I think that was, oh, I forgot. What was the previous number again? I'm gonna put this here anyway. It's the same. And then the last, let's just, yeah, probably remove Kingsley for now because he doesn't seem to be in the chat. 151. 151 would be Kevin. Let's just vote it for now. $161. $161. Swawadilla. I'm not sure if I'm pronouncing it correctly. Okay, so Kevin is in the chat. Angela's here. Wait. Who was it again? Leslie was here. Where was Leslie? Oh, there we go. So we have had 3 confirmed so far. Alan Wang is probably not here. Okay, we'll roll probably 2 more times then because Alan is probably not here. And we get 153, which brings us to Isabella. Let's just vote this for now. Yeah, we'll wait for a few moments for them to if neither Isabella nor Alan is in the live chat, then we will roll a few more times. Okay, I guess they're not. So let's just remove these 2 and roll 2 more times. $61. Which is Hao, if Hao is here. And 1 more, which would be 55, I guess. Andrew. Isabella is here. Wait, Isabella is here. Did we unboard it already? Oh, wait. So Isabella and Andrew, I think, well, the final 2, I guess, probably. Is that the correct number? I've lost track. This live thing is a bit. I think Hao is not here, right? As far as I can tell, so this is fine. So 1, 2, 3, 4, 5. Yeah, I think we have all we need here. We will reach out to you after the event on Slack or something, or email, and then we'll reach out to you then. And then without further ado, we can move on to sponsored prizes, which Elizabeth is gonna talk about.
Yes, so now we'll be announcing the prize winners of the sponsored challenges. These prizes were determined by the sponsors that offered these challenges, and each sponsor will be following up with the winning team members. If there are any logistical concerns, please let us know in the Slack or email us. So first we have Citadel's Challenge, which awards the best COVID-19 related hack. And the prize is $1,200 in cash split amongst the winning team members. The winner is the COVID Resource App team. Congratulations. Next, we have YHack's Environmental Impact to Action Challenge. This is an award for a hacker tool that would be used to educate someone who denies the science of climate change. The winner of this hack is the team One Earth. Next, we have Digital Assets Challenge, the best use of DAML to make a social network, app, or website. This is an award for the team that creates the best and more most democratized version of their favorite social media app or website using demo bonus points for deploying their application between multiple participants. The winner is COVID-19 Plasma Donation Social Media Team. Now we have Facebook's challenge, which is to build community and bring the world closer together in a COVID-19 world. The winner of this challenge is Potluck. Next, we have Google Cloud. Google Cloud this year is offering 2 prizes. The first is for the hack that best uses any Google Cloud product. The winner is COVID Resource App Team. The second challenge of Google Cloud awards 3 prizes for projects that best focused on building solutions for challenges related to COVID-19. The winners are PlanWise, Potluck, and the COVID Resource App Team. Next, we have Ripple Match, awarding a prize for the best hack that connects college students actively looking for jobs or internships. The winner is the Tutory team. That concludes our sponsor challenges winners.
So our judges are still deliberating in the breakout room. Yeah, we will stay tuned and wait for a while here.
A few moments later.
Without further ado, I think the judges are slowly coming back into the room. We can pass it to Justin, who will be talking about what happened and the final results, I think.
Sounds good. And so I think Jesus is going to announce the final winner, but it was very close. And as you can tell, the judges spent a lot of time debating. You guys all did a really great job. They were all impressed with how much you guys were able to accomplish in 1 week. And so we're going to announce the winner now. Jesus, do you want to unmute yourself?
Yes, I am unmuted already. Do you see me as muted? I am unmuted.
Oh yeah, so
We
you
hear
can go ahead and announce the winner.
But I still don't know who's the winner. So
I sent it to you in
all
a
right,
chat.
you put it on the chat. All right. So am I live? I mean, at the end of the day, I still don't know.
Oh, we're live.
So all right, then we are live. So thank you very much, guys. I really, really appreciate for all of you that participated. You are all winners, and you know why? Because you learned a lot. We were one of the 4 points that we were looking at. That was this exactly. What did you learn all this time? You learn many other people. You learn many other possible mentors for your career, and you learn about new technologies, new ideas. And this is the best thing that you can do in a hackathon always. So you are going home with a prize, no matter if you are going to be named now or not. We were deliberating about this top 5. We had practically everybody had a sponsor, let's say like this, yeah. At the end of the day, we decided to go for one, which the name is Maskify. Why did we decide to go for Maskify? And congratulations, guys. I really liked your project personally. We think you had all the 4 points that we were looking at. You had them really very well represented in your project. You were learning all the time. You use different technologies from the Google Cloud platform. You can be really very proud of it. You really got a project, a concept project behind this. You are making something impactful. You are making something that can be very useful, and particularly in this situation today. We are living extraordinary times, and extraordinary times need extraordinary projects and extraordinary people that can do things. Really, congratulations. Thank you very much for having been at the Yale Hackathon. And I hope we will meet all of us one day again without COVID in real life, yeah? And so that we can celebrate properly your win. Thank you very much, guys.
All right. So that brings us to a close for the overall hackathon prize. Justin, you want to talk about the final notes?
Great. And so before we go to the next slide, we will follow up with the winning team over email directly. So be sure to check your inbox for that. As always, if you have any logistical concerns, please ask them in the #AskOrganizers channel on Slack. Great. Next slide, please. And so some final notes is we'd love to get your feedback as well as get your t-shirt sizes. So this form is like combined. So if you submitted a project and are in the US, then we'll be shipping a t-shirt to commemorate YHack V 2020 to you free of charge. Unfortunately, we are not able to ship swag internationally. And yeah, so everybody, please fill out this form by November 17th, 11:59 p.m. Eastern time. And just want to reiterate again, if you are one of the winners that were announced, congratulations, and be sure to look out for an email in your inbox. And with that, we will bring YHack 2020 to a close, and we will hopefully see you at YHack 2021 next year, and hopefully it'll be in person. Thanks so much, everyone, and we hope you have a great rest of your weekends.
Bye, everyone.
Everybody.
Bye.
Thanks a lot.
Bye.
Ciao.